Diagram show one triangle, and they say, state the coordinates of R. The coordinates of R is going to be, the X coordinate is 0, and the Y coordinate is 3. And that's it. Nice and easy. On the diagram above, draw a triangle P prime, Q prime, R prime, which is a reflection of triangle PQR in the line Y equal 1. Draw a triangle P prime, Q prime, R prime, which is a reflection in the line Y equal 1. So first thing I like to draw, I want to draw the line Y equal 1. Before I reflect anything, I like to draw the line that I need to reflect in. The line Y equal 1 is this line right here. So this is acting like the quote unquote mirror. That's the line Y equal 1. That's acting like the mirror. And then it says draw the triangle P prime, Q prime, R prime in the line Y equal 1. So drawing this in, reflecting it in the line Y equal 1. So this going to be, this is R is 2 centimeters away from this line. So 2 centimeters away will be R prime. This is 1 centimeter away from here. And so this is also going to be 1 centimeter away from here. 1 centimeter away from here is here. This is now P prime. Now this is 1, 2, 3, 4 centimeters away from the mirror line. So 1, 2, 3, 4 centimeters away from the mirror line. Right? And so this will be R prime, this will be P prime, and this will be Q prime. And that's it, nice and easy. All left to do is just draw your triangle. That's a triangle, nice and easy. Then what's next? Oh, also, it's always very good to label your line Y equal 1. Next thing they ask us is to draw another triangle. And they say, draw a triangle P double prime, Q double prime, R double prime, which is a reflection of triangle P prime, Q prime, R prime in the line Y, in the line X equals 0. So the line X equals 0, let's use green. The line X equals 0 is the y-axis. This is the line X equals 0. All right. So now we're going to reflect. We're going to reflect in the x-axis. So I'm just going to label it. This is the line X equals 0. And we reflect in this line X equals 0. So this is acting like the mirror now. So this is now 2 centimeters away from the mirror. So we go 1, 2. And so this is P double prime. This is 2 away from the mirror. So we go 1, 2. And so this is Q double prime. Now, this is on the mirror, so it stays right there. All right. So all we have to do now is label the points. This is Q double prime. And this is P double prime. That's so good now. And that's it. Nice and easy. Oh, and label it as R double prime as well. All right. And that's that. Nice and easy. It's always nice to just do a little drawing and get some marks. No issues. It says describe fully the single transformation that maps triangle P double prime Q double prime R onto triangle P Q R. So describe fully the transformation that maps triangle this. What? Let me read this again. Describe fully the single transformation that maps this, the image triangle, back onto PQR. So what's mapping this onto this? Now to do this, I love to identify my points. So I notice that my P double prime is the point, let me see, P double prime is the point -2, P double prime is the point -2, P double prime is a point -2, 0, and it is mapped to P, and it's going to be mapping to P. P is the point. This look like 2, 2. This look like the point 2, 2. All right. And then I need to write down what is my, let's use Q double prime as well. Q double prime is the point. Q double prime is the point. This is Q double prime is the point -2, 3. Q double prime is the point -2, 3. And Q is the point 2, 5. Q is the point 2, 5. So let's see if we can write down the transformation now. All right. Now, as you can see, we'll go from -2 to 2. -2 to 2, so that becomes negative of x. And then to go from 0 to 2, we'll add 2 to it. Q double prime, we'll add 2 to it. We're adding 2 to it. And we keep looking. So as I said, we reflect it over here. Reflect it in the line x equals 0. Then reflect it in the line y equals 1. Two reflections generally give you a rotation, but the tricky thing is it's not y equals 0. Generally, we could just say it's a 180 degrees clockwise rotation about the origin, but because it's now the line y equals 1, it's different. So let us see. It's just a 180 degree clockwise rotation, but it's not about the origin anymore because of this line y equals 1. So let us see. X being 0. Oh, let's just think of this now. It's just pretty much a 180 degree rotation in the clockwise direction. And we're just going to take this as the center, about the point 0, 1. This makes sense. This is the center. Think of this as a new origin. Think of this point as a new origin, and this as the x-axis. So it's a 180 degree rotation about the center being 0, 1. That suffices. All right, this line y equals 1, yeah, push it up. This was what was throwing it off a little bit. So it's a 180 degree rotation. Describe fully the single transformation. It is a 180 degree rotation in the clockwise direction about the center being 0, 1. That's it. It's just a 180-degree rotation in the clockwise direction with the center being 0, 1. All right, we weren't going to get the matrix like this. Ignore this, because that was throwing it off. The line y equal 1 was throwing it off. All right, so you have to be careful for that as well. Be careful of your center. Be careful of your center. They tend to do that sometimes. They might give you the line y equal 3, y equal 4, something. You have to just be careful with the center now. All right, so as you can clearly see, think of this now as the center. You rotate it here. You reflect it here, then reflect it here. Reflection followed by reflection is 180-degree rotation. But then rotation about where? Not the origin. Rotation about the point 0, 1. All right, that's now the new center. See, they're 2 units away from here, 2 away from here, 1 away from here, 1 away from here. Yeah, that's it. Look at it from over here to over here. This distance from here to this distance here is the same as this distance from this distance. This distance from this distance are the same, and this distance from this distance are the same. So this has to be the center. So it's a 180-degree rotation about the center, 0, 1. Now it's now to triangle PQR undergoes an enlargement of scale factor 2. Calculate the area of its image. Triangle, which one again? Triangle PQR undergoes an enlargement of scale factor 2. So triangle PQR undergoes an enlargement with scale factor 2. And then what would be the area of its image? All right, now, if it undergoes an enlargement of scale factor 2, right? I just want you to picture what's happening. All right, I just want you to picture what is happening. If I give you a triangle, I'm just making up something. Let's say I give you a triangle, right? This is a triangle with, let's say, a height of 2 and a base of 1. If this is this triangle, right? And I tell you that I enlarge it with a scale factor of 2, right? And so the height becomes 4 and the base becomes 2. Now look what happened. All right, now the area of the smaller triangle would be half base times height, which is a half of 1 times 2, which is 1. And the area of the big triangle is going to be a half the base 2 times half of 2 times the 4, which is 4. So the area of the big triangle is 4 times the area of the small triangle. So what am I telling you? The area of the image is going to be 4 times the area of the object. That's all I'm trying to say. So that's all we can write down right there. So the area of the image is going to be 4 times the area of the triangle. So let's go and deduce the area of triangle PQR. So the area of triangle PQR is equal to area of triangle PQR. PQR. The area of triangle PQR, you can actually count up the squares. Look at this. 1. This is going to be 1. This is 1 full box. This and this make 2. This and this. Really and truly, that looks like 3. The area looks like 3. How do I know that? If I were to split it in 2 triangles right here, right? Split it in 2 triangles. So think of it as 2 triangles, all right? The area of this triangle would be, the height is 2 units and the base is 1. So the area of this triangle is 1. And then this side now, the base is 2 and the height is 2, and so the area up here is 2. 2 plus 1 is 3, and so the area of triangle PQR is 3. So the area of triangle PQR is 3 units. And so the area of the image, now I'm going to call it I. The area of the image is 4 times the area of triangle PQR. So the area of the image is 4 times 3. And 4 times 3, as you know, that's 12. All right. That's 12 units square. 12 units square. Now the formula is coming back to me. Always remember this, the area of the image is equal to k squared. Whatever the scale factor is, if the scale factor is k, then the area of the image is k squared times the area of the object. All right, that's the formula. If you don't like to reason it out like this, you can use the formula. Area of the image is k squared times the area of the object. Just came back to me.